Welcome to my channel guides, learning platform for engineers. So today we are going to learn the reinforcement, the analysis of singly reinforced beam. Analysis of singly reinforced beam. So in the name singly means once in a beam the reinforcement is provided. The analysis is done by for three types. First is the under reinforced section. Second, balanced section. Balanced means where neutral axis and maximum depth of the neutral axis is at an equal point. And third is the over reinforced section. Over reinforced section means reinforcement provided in the singly reinforced beam is at the compression side. So first we have to find the actual depth of neutral axis. So actual depth of neutral axis denoted by XU. XU is equal to 0.87 FY ASC divided by 0.36 FCKB, where means in this formula AST is the area of tension steel, or area of steel in a tension, So second is Fy. What is y? Fy, grade of steel. Fy is the grade of steel for 250 Fe 250 Newton per mm square. For Fe 415 Newton per mm square. For Fe 500, these three grades we are used, so 500 Newton per mm square. What called Fe 250? It is called as mild steel. And what called Fe 415 and 500? HYSD, highly yield. So therefore B is the width of the beam. So this is the actual depth of neutral axis. Secondly, we have to find maximum depth of neutral axis. So what is the maximum depth of the neutral axis? XU max is equal to 0.53 D for Fe 250. XU max is equal to 0.48 D. D is the depth of the beam, or effective depth of the beam, not an overall. It is the effective depth of the beam. When we go to the example, I show it what is the effective depth, what is the clear cover, and what is the overall depth. So this is 48 D for Fe 415 and 0.46 D for Fe 500. This is the maximum depth. This value 0.53 D, 0.48 D and 0.46 D. Page number 70 of the IS 456-2000 latest IS code. IS 456-2000, page number 70. From page number 70 we get these three values. So for the next third step, compare equation 1 and 2. What is the equation 1? Actual depth of the neutral axis. What is the equation 2? The maximum depth of the neutral axis. So here we go. Compare equation 1 and 2. When XU is less than XU max, it is the under reinforced section. Under reinforced section. And when XU is equal to XU max, then it is balanced section. And when XU is greater than XU max, then it is the over reinforced section. So these three conditions are very important. Reinforced section. So in the step number 3, we are compare XU and XU max. Then in step number 4, the XU in step number 4, for the moment of resistance, when XU is less than XU max and when our section is under reinforced, then formula for moment of resistance denoted by MUR is the 0.87 FY AST XU into D minus 0.42 XU, and it is for under reinforced section. Under reinforced section. And this, in this formula, XU is what is the value of XU? It is the value take from equation number 1. And what is the D? D is the effective depth. Effective depth, not the overall depth. It is the effective depth. When MUR, we are going to next condition, balanced section. It is never happens in a beam because XU means actual depth of the neutral axis and maximum depth of the neutral axis cannot be equal, or equal in rarely case, where in an ideal case XU is equal to XU max. You have to memorize it. When MUR in a second step, when balanced section, either balanced section or XU is greater than XU max, then MUR is equal to 0.36 FCKB XU D minus 0.42 XU. And what is the value of XU? XU is equal to XU max. So XU is equal to XU max. And D is the effective depth. Effective depth. When the section is under reinforced, then suppose this is the shear force diagram and this is the neutral axis, then it is the XU, means this is the depth of XU. Neutral axis in below of neutral axis, it is called as under reinforced. And when just think, this is the neutral axis and this is the XU, means above the neutral axis is called as over reinforced. In these two diagrams are not clearly shown, but this is the compression side, and in over reinforced section there are occur the compression failure, and in the under reinforced section there are tension failure. In this section here is tension failure and here is the tension side. Thank you guys.